Hi everyone, Miss Andronicus here, and today we are looking at mutually exclusive outcomes. So, mutually exclusive outcomes are outcomes that cannot both happen at once. So it's like when you're flipping a coin, you're either going to get heads or tails. You can't get heads and tails happening at the same time. So as a result, if you add up or find the sum of all of the mutual exclusive events, they must equal 1. Because, of course, one of them is definitely going to happen, and so then you know it's a certainty. So have a look at the probability of heads is 0.5, or as a fraction 1/2, same thing for tails. As a decimal it's 0.5, or as a fraction it's 1/2. You could give that probability as a percentage, 50%, therefore it would equal 100. So here's an example with a regular die. When you roll it, what is? Okay, so first of all, a regular die, you know, has 6 even sides. So this question A is asking what is the probability of, and it's everything in those brackets. So the probability of a 1 or a 2 coming up. Well, you know the chance of a 1 coming up, the probability of just 1 is 1/6. The probability of just 2 is 1/6. So put them together, the probability of both of them is 1/6 plus 1/6, which equals 2/6, which, yes, they need to be simplified because that is a fraction. It's going to be 1/3. So the probability of a 1 and a 2 coming up is going to be 1/3. B is asking the probability of 3, 4, 5, or 6 coming up. So any of those options. Now, there's 2 ways I can approach this. First of all, it's taking into account every single option outside of what I just calculated for 1 and 2. So I can note that. If I note that, I can say, well, putting it all together, that's got to equal 1. So if I'm asking what the leftovers are, it's not 1 and 2, it's 3, 4, 5, or 6. It has to be the remaining 2/3 of a probability, because 1/3 plus 2/3 is a whole. Or I could prove it by saying, well, the probability of a 3 is 1/6, the probability of a 4 is 1/6, the probability of a 5 is 1/6, the probability of a 6 is 1/6. Altogether, that's 4/6, which again is 2/3. Example number 2. Okay. On a spinner, the probability of the colors are shown below. So what's the probability of spinning yellow? Okay, so again, these on a spinner, they're mutually exclusive. You're not going to get green and yellow at the same time. Because they're mutually exclusive, I know all the probability must add up to 1. So I'm going to sit there and add all of them up first. Okay, so 0.25 plus 0.3 plus 0.1. So I need to add all of those up first. So that's 0.65 altogether. Now I know the whole thing has to add up to 1, so I need to do that subtraction. Okay, and if I do that subtraction accurately, I know that's going to be 0.35. Okay, 0.35. And that's the probability of spinning yellow. So I would present that answer by probability of yellow, use the format P, brackets, etc., is 0.35. Okay? Give that a go. Good luck, everyone.